Okay, so let's solve one more problem about this story of the magnitude of the magnetic field. So what is the problem now? We have two parallel straight wires 10 centimeters apart. Okay, so this is one wire, this is another wire. They are both horizontal. Okay, they are both horizontal. They are crossing the screen. Okay, so if you're looking at the screen, these wires, they are going from your nose through the screen and to the back of the screen. Okay, this wire here is carrying this current I1. The magnitude of this current is 5 amp, and this current is going out of the page. Now remember, the dot is indicating that this current is coming out of the page towards your nose. Okay. The other wire here is carrying another current. The current is I2, 7 amps. Okay, so there is an extra dot here, it's just 7 amps, and this one is going into the page. Okay, so into the page, crossing the screen. We want to know what is the magnitude and the direction of the magnetic field halfway between the two wires. So we want to know what is the magnetic field right here at this point between the two wires. Okay? Okay, before we do anything, let's discuss the magnetic fields created by each one of these currents. So this one, the I1, is coming out. So you put your thumb coming out of the page. Okay, your thumb is coming out of the page towards your nose. And then with your four fingers, you're going to encircle this wire. So encircle it, so your four fingers will be closing this wire in this direction. Very well. What is the direction of the magnetic field? Well, this whole thing, this whole circle is giving us the direction. But at each point, we have a different direction then. So if I pick this point here, right here, at this point, what is the direction? The direction is the tangent of this circle. The direction at this point is pointing to the left. Let me pick another point. This point right here. What is the direction of the field right here at this point? Well, it's the tangent of this circle, so it's pointing down. What is the direction here? The tangent at this point, which is pointing to the right. So what is the direction of the field right here between the two currents? The B1 caused by this current I1. Right here, it is pointing up. Following this circle, right here, the tangent is pointing up. Okay, let's now look at the current I2, which is going into the page. So again, what are we going to do? Use our thumb to get the direction of the current. So you're going to put your thumb now into the page. Okay, put your thumb pointing towards the page, and with your four fingers encircle this wire. And what the four fingers will tell us that we get this direction here, this circle here for the magnetic field. So again, I can select individual points to get the direction of the field, which is the tangent at that point of the circle. So for example, right here, the direction of the magnetic field right here is the tangent, so pointing to the right. Okay, right here, it's pointing to the left. Right here, that point between the two wires, right here, the magnetic field, the B2 caused by the I2, is pointing up. Okay, so right here, this point, we have that B1 and B2, they are both pointing up. So the sum of the two will give us a magnetic field pointing up. So we can already say one of the questions of this problem is what is the direction? Well, the direction of this total magnetic field is up. At that point between the two wires is pointing up. Now, what is the magnitude of this field? Well, this magnitude, this total, this net magnetic field will be the B1 plus the B2. Okay, what is the B1? Well, let's use this equation here. That constant divided by 2 pi I1 divided by the distance from the wire. So this point here is 0.05 meters, not 5 centimeters, 0.05 meters away. So I'm going to put here 0.05 meters. How about B2? Well, the constant also, the current I2, and the distance, well, the distance is the same, so 0.05. Okay, so put all these numbers there. Remember this constant is given to you here. Put all these numbers there and double check that you get this result. 4.8 10 to minus 5 Tesla is the net, is the total magnetic field.